What is up, most distinguished patrons of this channel, and you guys and girls that are just stopping through to see what's going on. Today we are going to be tackling Spray Arc Part 2, which if you haven't seen the first part, the link is in the description. Go and watch that and then come back and watch this. If you're already familiar with Spray Arc and just want to see some hands-on testing, stick around for this video. So in this video, what we're going to be tackling is a direct comparison between short arc or short circuit MIG and spray arc to see what the differences are in penetration, strength, cut and etches, everything to do with that. So let's get into it. So the benefits of spray arc in theory is that you get a lot better penetration on thicker materials, so 1/4 inch, 3/8 and up. It gives you higher metal deposition rates, so you can basically get a single pass weld done and you have a bigger weld, and it also is faster because you move faster. So for production on, say, 1/4 inch, 3/8 and up, very beneficial process. Obviously, there's a lot of drawbacks to it, the primary one being you need a pretty expensive big welder and a lot of power to feed to it in order to do spray arc. Spray conventional that is not pulsed, you can't run vertical up or overhead. So that's a pretty serious drawback. It's flat and slightly horizontal only. And then beyond that, it takes special gas mixtures. So you may have additional costs or an additional cylinder you need, and you can't weld thin material with it. Good luck trying to weld 1/8 inch with this spray. So a lot of drawbacks, but a lot of benefits. So the setup I have today that we're going to do all sorts of testing on, we're going to do 2 fillet welds on 1/4 inch. We're going to do 2 lap welds 1/4 inch. We're going to do 2 brake tests on 1/4 inch and 2 brake tests on 3/8 inch. And we're going to use what I would consider the correct or maybe fairly hot settings for short circuit MIG on one of each, and then we're going to do spray arc settings on one of each, and we're going to directly compare and contrast the differences. And one of the things you guys got to understand, and this goes back to what I said in video 1 on this series, spray arc essentially at the bottom of the set points for spray is at like the top of what short circuit will be at for penetration. So essentially spray takes over as short circuit starts to fail. And by fail, I mean when we get to the 3/8 plate, I have a feeling the difference is going to be far more significant than on 1/4 inch. Because 1/4 inch thick steel, short circuit is perfectly capable of welding and getting decent penetration. However, when you start getting up to 3/8, especially on a fillet weld, you're going to run into problems with that, and 1/2 inch even as well. Because the lack of heat, you're going to lose root fusion. You're putting down too much metal and you can't get that wire to fuse the root together, which is why heavy plate and industry, they don't use short circuit MIG to be doing welds like this on 3/8. But hey, that's the point of comparing and contrasting the limits so that you guys become better welders yourselves because you understand what's going on. So with that said, I'm going to start welding all of these up. I'll start with the short circuit process and weld all of them, then switch to spray weld all of them, and then we'll go through and investigate each one. All right, so I got everything welded up and I thought we would do a little bit of an inspection. So these we are not going to be brake testing. I'm just going to saw cut them in half, and we're going to look at the middle of the weld to see what's going on, because that's going to be the most consistent. This guy, I ended up having an issue where I tried to weld it and realized that the whip was caught underneath my seat and I couldn't move, so I had to stop, restart. For the sake of this test, it won't matter because we're going to be cutting it right down the middle where it should be, I guess, that most average for fusion. This was obviously the spray arc. It produces a much wider weld than the short circuit MIG. This was done with a pull angle, which if you saw my previous video on push versus pull, you would know that pull should have more penetration on 1/4 inch plate than pushing, which gave it a little bit more of a roped up profile. Now, I could have moved a little bit slower on this to produce a bigger weld, but I think with the fusion that this is going to have, it'll be roughly appropriate in size for 1/4 inch. This is a little bit oversized, and that's where dialing things in. Had I spent a couple hours to really get things dialed in, I could have likely made a little bit smaller of a weld, equally as flat. You get the picture. So there's a lot to be said for dialing things in. And since we're not brake testing these, I'm not too worried. We're looking at the penetration differences, less so the strength. The ones that we brake for strength, those are actually far closer. So now on the lap welds, I didn't do the best job, and I'll blame myself on that. Both of these were pulled. Pull tends to make a ropey bead profile, especially with short circuit. And guess what? The bottom toe looks cold. I'm sure it's going to have plenty of penetration. If I would have pushed, it would have flattened this out quite a bit, and I wouldn't have nipped this top plate as much. That's my bad on it. But again, we're looking at the penetration differences. Here with the spray arc, I would say my settings were a little bit on the hot side. It nipped the top part of the plate back quite a bit. So again, there's all sorts of ways to deal with that. Slowing down to let it fill a little bit better, or using reduced settings. There's a number of ways you could tackle that. But I'm going to cut all of these open, etch them, and then we're going to look at what's inside and direct compare these two. So these results aren't the worst or not the best, and the penetration is actually a little bit better than what you see here because the top edge of that plate burned back a little bit. But this is pretty much it. You're not going to get better than this with the short circuit process. If you switch to spray or dual shield, you could see better than this. But this is basically the upper limit on 1/4 inch of what you could expect. So now let's look at spray arc. So right here we can see a huge difference. It's still burned that top plate back, so the penetration, much like the short arc, is a lot further than what it looks like. But you can see that little nugget in the center that burned way in there. Now you're probably asking yourself, well, couldn't you just do multiple passes to gain the strength back with the short circuit? And the truth is, yes, you could. The problem with doing that, though, is that if you don't achieve root fusion, depending on what you're welding and how it's stressed, it may still be weaker than if it had more root fusion, if that makes sense. So you can't always just weld yourself out of a corner. So it's something to think of there. Also, keep in mind, if you're in the habit of doing single pass welds on stuff, and you don't go back and do multiple passes, well, which one would you rather have, this one or the short circuit weld for a single pass? I think we all know what the answer to that question is. All right, let's look at a fillet weld done with short circuit. So once again, not the best, not the worst. This is pretty acceptable, and this is about what you're going to see. Now, I was using 035 wire. If you used 045 wire and ran a lot more amperage, you'd probably get better results with this, but a lot of your guys' machines probably won't run 045 wire due to a lack of amperage and a lack of parts like your drive rollers and your contact tips. You might not even, and even a liner, you might not even be able to get it for your machine. So again, this is the best that you can expect out of 035 wire with C25 gas. In a future video, I'm going to tackle C100, so 100% CO2 versus C25, and I think that the 100% CO2 might actually be better than this. The downside being you need even more voltage to run it, and your machine may not even have that, so all things to consider. Well, let's compare this to spray. as expected, vastly improved penetration. Now, I hit the upright plate a little bit more than the bottom plate, and that could be rectified with a gun angle change, and it really goes to show the importance of doing a cut and etch so you can see where the hell you are. You know, so many people will weld for years and years and years and never do a cut and etch, and you know, come to find out they're barely getting any fusion whatsoever. And don't rely on the fact something hasn't broken yet on you for proof that your welds are strong. But yeah, so this isn't bad, and again, massively increased penetration. Now this will be a stronger weld, no doubt. I mean, for one, it is bigger. The throat depth from the depth of penetration to the face is bigger than a short arc MIG weld, so that alone will add strength. But by fusing that root, it makes it a lot harder for that plate to use the weld as a fulcrum point of sorts and flex and bend off, and it's far less likely to break due to vibration on the plate. Say that was on a trailer or something. And keep in mind, this is just a single pass weld. Which would you rather have, this weld or the short circuit MIG as a single pass? Again, I think I know which one we want. All right, let's look at both of them with the settings I used. So these are the same two welds that we just saw. And as you can see, the wire feed is actually not that much different between the two. The big difference is the voltage. The short arc 21.5, the spray 26, and then of course the shielding gas. In case you're wondering, if you were to take that short arc MIG weld and then up the voltage at 25 volts, you would not see results like you do with the spray. And that's because it's a combination of high voltage and shielding gas differences. So unless you're running C10 or some other spray mixture, you're just not going to get that kind of performance no matter how much amperage your welder has. Now again, if I had used 045 wire and higher amperage, like above 230 amps, maybe the performance of penetration would be a little bit better with the short arc. But again, there's no substitute for voltage in the right shielding gas. So what did you guys think of the differences there? Pretty significant, aren't they? And the reality is that's why spray arc is used on 1/4 inch and above steel. It just gets more consistent and reliable fusion, way more penetration. I mean, basically you actually do get penetration, measurable penetration, and the overall performance is good. Now, without a doubt, I could have done a better job. And honestly, the settings were a little bit hot for the spray for the 1/4 inch. So had I downed the settings a little bit to be a little bit more controllable and produce a little bit better looking of a weld, not so blown out, to be honest, the penetration would have been a little bit less. But again, spray, basically the least amount of fusion you're going to get is where short circuit MIG ends at. So whatever you think you can get max with short circuit, that's the start of spray. So they're really two night and day difference, I guess, two completely different processes with different results. Now, based on this, I think you can make a pretty accurate assumption as to how the brake tests are going to go for strength. So let's go over and do that. So in this test, we have all the fillet welds lined up, and I'm going to break them towards the face, and I'm going to measure what the actual braking strength is. To be honest, this is less of a concern than what we find inside when we inspect it up and close on the camera after they're broken. But the reason I do this is because the higher the number on this, the higher the root fusion is going to be. Now, normally, if you're going to weld something and it's going to experience stress towards the face, so this way, and you're not welded on the back side, you would have an oversized weld on this side to help negate the strength loss of having basically no weld on the other side. Well, we didn't do that in this test. We're mainly looking for how much penetration and quantifying the differences in penetration via a torque gauge. And the higher the number, the better the root fusion, the better the penetration is going to be. Now, I would predict that the spray arc is going to have a significantly higher braking strength than the short circuit MIG, and the simple reason is that there's more fusion and penetration past the root on that due to the differences in the process. Now, a normal result on 1/4 inch plate for short circuit MIG is somewhere around 90 to 100, 105, in that ballpark. And if it's higher than that, it would be very good. If it's lower than that, it would be less than stellar. But short circuit MIG is very consistent overall. So let's see what this breaks at. So it broke at about 140, which a lot of that was actually just bending this plate, but that's a very good number for 1/4 inch. That means that we got very acceptable fusion on that. So now let's go to the spray arc and see what we have there. About 133, and it's actually not broken yet. So what I'm going to do is we'll just call that at the 133.34. Let's go on to the 3/8 plate. So here's the short circuit on 3/8 plate. $131 already cleared itself. And now let's look at the spray arc on 3/8 plate. So mistakes were made. I went and broke this first plate for the 3/8 spray arc, and guess what? The camera had died right as I started. So I welded up another one, and we're gonna break that on camera. The first one broke at a pretty absurdly high rating. So I expect this one to be the same. So let's break it. $209. That's quite a lot of force. All right, let's finish breaking all these and look at the internals. Let's start out looking at the 1/4 inch plate. So the short circuit is on the left, the spray arc is on the right. When I look at these welds, there's a lot of differences that are readily visible. Now, first off, the short circuit weld broke off the bottom plate, which I find short circuit in general tends to be pretty consistently inconsistent in fusion. And what I mean by that is, depending on what part of the weld, there's differences in what's actually fused. Like at the start of a short circuit weld, and most welds are cold, and the lack of fusion internally is very common. By the end of the weld, the fusion is really good into both pieces. So what you see with short circuit MIG is normally it will break off a one plate or the other at the start, barely taking any of the plate. There will be some fusion in the middle where it might take more out of the plate or break in the middle of the weld. And then at the end, normally it breaks in the middle of the weld due to the fact that there's proper fusion into both pieces. So this really shows inconsistent fusion overall, which is a reoccurring theme with short circuit MIG. Now this still broke at an extremely high strength level, and for you guys out there that are screaming that, well, stick welding is better, you'd be surprised. 70/18 1/8 inch rod probably would not have held up to as much force as this, just so you know. And I will be doing a video comparing all of that in the future. So anyways, we can see the entire original plate edge, arguably, other than maybe a little bit here, is all still there other than this end. But we can see it, didn't break it down, no root fusion, definitely no penetration. In direct contrast to that, the spray arc weld. If you look here, for I would say over a third of the weld, it literally chewed almost halfway through this plate, where no fusion, tons of fusion and penetration. The only area that's really suspect by a little bit is the start and maybe a little bit here, and that's it. So very good fusion. And actually the start, I believe, was on this side. It doesn't matter. No, it must have been this side. So great penetration, great fusion. So now 3/8 plates, this is a night and day difference. And this is where spray arc kind of comes into its own, definitely in another league compared to your short circuit short arc MIG. This is obviously the short circuit MIG, and the weld more or less just sat on this plate, and upon being stressed, it basically broke right there at the junction between this plate and just on the surface. Now this still broke at approximately the same strength as what 1/4 inch did, so it had some strength, but clearly not really good. And turning it up more from where it was, I ran a multitude of settings in the past with short circuit MIG on 3/8, and this is going to be a typical result. There's not really much way to get more fusion in the root or more penetration, anything with the short circuit process when you start talking 3/8 plate. And the problem is, and I pulled this, if I pushed it, it would have been even worse. I mean, this is a very acceptable looking weld, however, under stress, very common for it to just break off like this. So what I would consider this a very undesirable result. I would have liked to have seen it break through the weld, not just right off the surface of this, because that weld was basically just sitting on there. Now spray arc, which was run at higher settings, different gas obviously, and much higher voltage, the weld broke more or less down the middle, so that's desirable. Okay, it didn't just delaminate from the plates. And when you look at the difference in there, look how much it chewed into this plate. So it actually broke down the edge. We actually have not only root fusion, but penetration. And let me zoom in. When you look here, better than, I would say, 80% of this, the original edge is broken down. There's almost nothing touched on this short circuit weld at all. So this, much more desirable results. And it goes to show in the brake test, it broke at like over 200 foot-pounds of torque on my little test apparatus, and that's a direct result of that root fusion. Now the welds themselves really aren't that much different in size. If you actually compared the thickness or the quantity of metal between the two, they're pretty similar. The spray arc is definitely a flatter weld, so it's wetted out to the sides a little bit better. This really goes to show the differences and why you probably don't want to use short circuit MIG on 3/8 plate. Now, again, I know you guys are probably saying, well, stick welding would do better than short circuit MIG on 3/8, and guess what? In the future, I'm going to be testing that and comparing it, because there's a lot to be said with that, because stick is not the end-all be-all when welding thick plate. You have to know what you're doing and use appropriate settings. All right, let's go to conclusion. All right, so what did we learn today? Well, we learned that spray arc, even at the lower end of the spray arc, so sub 230 amps or so, performs extremely well on 1/4 inch plate and 3/8 plate, which we knew that it would, because, well, it's a completely different process of wire transfer, I guess. I don't mean to beat a dead horse on it, but you guys understand that the importance of testing what you're actually doing. You know, I hear a lot in the comment section commonly, well, just crank it up 5, crank it up 10. And I have numerous other videos with stick welding especially, where I prove that just cranking up amperage doesn't net you more penetration, because it's all in relation to travel speed, heat input, and generally, the more wire you feed, the faster you end up moving, or the puddle gets out of control, thus the less root fusion if you get too extreme. And that's, again, based on 035 wire. Had I used thicker wire like 045 or bigger, we could see maybe more root fusion despite going faster, and that's simply because we can get even more amperage out of that wire. It's all things to consider. Now, unfortunately, the settings I used today for most of this, even the short circuit settings are literally at the absolute limit of what your 200 amp home MIG welder will probably handle, to be honest with you. And it won't like too much of that. Now the spray arc settings, I was up over 220, 230 amps for some of it according to the machine. That's well beyond what your machine is likely capable of. And even if it was, you got to watch that MIG gun because you're probably going to have a meltdown doing a bunch of it, as well as a duty cycle probably won't keep up. All things to consider. But the main point I'm trying to make with this is that short circuit MIG is an awesome process. It's incredibly strong on 1/4 inch. 5/16 to a certain extent, yes. When you start playing around with 3/8 plate, short circuit MIG can produce strong welds, but they are also weak in comparison to a proper process. And unfortunately, a proper process with wire processes, so GMAW, is going to be spray or dual shield run at 230 to 300 amps, which is well beyond the equipment you probably have. So it's one of those things. I'm not trying to bash short circuit MIG or wire in general. Both of them are awesome processes. You just need to know when to use one and when to use the other, and you also need to understand the limits of your equipment. And it goes to say, same thing with stick. You know, if you're trying to weld 3/8 plate and all you have is a 100 amp welder, good luck. You're not going to be able to produce very strong welds more than likely. And also, beveling, I got a video coming out on that because I know a lot of you have been screaming at the screen right now saying, well, why didn't you bevel the plates? It's instant strength. You'd be surprised at how little the effectiveness is on beveling depending on what you're doing. And that'll all be out in that video, so that'll be out soon. With that said, thanks for sticking around, guys. Hopefully you learned something. If you got any comments, questions, thoughts, feel free to leave them. Until next time.